SQA 2022 Paper 1, Question 14, the final one of the paper, this one, and it was a circle question. It says circle 1 as equation x minus 7 squared plus y plus 5 squared, and it equals 100. State the centre and radius of the circle, and then hence or otherwise show that the point minus 2, 7 lies outside the circle. Part B is another circle with centre P and R. Determine the values where C1 and C2 have one point of intersection. So there's our formula sheet for circles that you didn't have to memorise, although you should probably know it by now, but it tells us the centres quite clearly. We've got 7 minus 5 as our centre for 1 mark. So for part A1, all we had to do is write down 7 minus 5, and that gives us a mark for our centre. And then remember, looking at the formula sheet, we can work out the radius, because if it's in already factorised form, the right hand side equals r squared, so we can write down r squared equals 100, therefore r equals 10 because it's the square root of 100 for our second mark. Nice to start off with there. So let's move on to part 2 of the question and zoom a little bit. Part 2 says hence or otherwise show the point minus 2, 7 lies outside of circle centre 1. Well, we can just substitute point P into the circle and check, does it actually equal 100 or not? So, part 2. So our P equals minus 2 and 7, which is our x and y. So we've got, for 1 mark, substituting that in, minus 2 take away 7 squared plus 7 plus 5 squared is minus 9, all squared, plus 12, all squared. That's 81 plus 144, which equals 225. So that's our third mark, or the first mark of part 2. For substituting in and working out to equals 225, we get a mark. Then we need to actually say what that means. So we can say that since 225 is bigger than 100, P must be outside the circle. Since 225 is bigger than 100, P lies outside the circle. And there we are for the next mark. So we've got 4 marks already. 11 part B says that C2 is a circle with centre P and radius R. Determine the values for which C1 and C2 have exactly 1 point of intersection. So you've got 2 options. If I draw a circle here, then we'll call this C2. And its centre is P, which, if we remind ourselves, was minus 2, 7. And then we've got our first circle, let's call it C1. If we move that over so it's touching, the centre of that circle was 7 minus 5. So if they're touching at 1 point, they're just touching externally, so that the radius, let's call it R1 plus R2, would be the distance between the circles. So R1 plus R2 would be the distances. Now we know that this radius for our first circle is already 10. We don't know the radius of our second circle, but we can work out the distance between the circles. So using the distance formula, R1 plus R2 equals x2 minus x1, 7 minus minus 2 is 9 squared, minus 5 minus 7, so plus 12 squared. 9 squared plus 12 squared is 225, which makes 15. The distance between the circles is 15. So that means the radius R1, in this case, would be 5, because 5 plus 10 is 15. So that's one option. But okay, so for the second option, we could have the 2 circles inside each other. And in that case, well, we already know that the radiuses together make 15. So the distance between these 2 circles is 15. But we already also know one other piece of information, that the radius of one of our circles is 10. And therefore, the radius of our other circle, 10 plus 15 is 25. R1 could be 25 for our second mark. So we get 2 marks, one for getting R1 equals to 5 and the other one for communicating that it must be 25.